Okay, let's wrap up this chapter and talk about how to conduct hypothesis tests for two population proportions. So some situations might require us to test a population proportion versus a mean. Let's say we are working with two samples and we're interested in knowing if there's a difference in a proportion for some attribute of interest in two populations. So let's learn about the hypothesis testing process for this situation. When working with proportions, first we must calculate the pooled estimator for the overall proportion. We take the sample size of the first sample times the proportion of that sample plus the sample size of the second sample times the proportion of the second sample. We then divide that by the sample size 1 plus sample size 2. Note, some problems may give you the sample proportion in the problem, and some you may need to calculate it when you're given an X or the value for the attribute of interest. Here is the z-test statistic for the difference between the population proportions. So here we have the sample proportions subtracted from each other. Here is the hypothesized difference, and like with working with means, this will be 0. Here in the denominator, this is the standard error with a slightly different format. We'll be plugging in the pooled estimator for p bar, then we multiply that by 1 divided by the sample size of 1 plus 1 divided by the sample size of 2. Let's go and review the variations in hypothesis testing for two population proportions next. So by now, this slide should look very familiar, but now we're working with proportions. Again, we have two-tailed test, one-tailed lower test, and one-tailed upper test. The two-tailed test is like working with two population means, but now we will replace the reference to the population mean with little p for proportion. So as a refresher, in the hypothesis statements, it is saying that the difference between two population proportions is equal to 0 or not equal to 0. In the second version, this is just written to say that the population proportion 1 is equal to the population proportion 2 or is not equal to each other. Two-tailed tests will always have the two rejection regions on both sides of the curve. For a one-tailed lower test, we are again comparing if the difference of the two population proportions is less than 0. That means the population proportion 1 is smaller than the population proportion 2, which you can see in the second version of the alternative hypothesis. We know this is a lower test since the alternative hypothesis is pointing to the left side of the curve. We reject the null hypothesis if the z-test statistic is less than the z-critical value. Finally, for a one-tailed upper test, the difference of the two population proportions is greater than 0. We reject the null hypothesis if the z-test statistic is greater than the z-critical value. The second versions, or the ones on the bottom of these boxes, are a little clearer for what we are testing for, so this is the style that I prefer. Just another reminder, when working with population proportions, we're only working with z values, so you won't have to calculate t values here. Let's go ahead and work on a practice problem next. Here's problem 10.58 from the textbook. Suppose a random sample of 100 US companies taken in 2015 showed that 21 of them offered high deductible health insurance to their workers. A separate random sample of 120 firms taken in 2016 showed that 30 offered high deductible health insurance plans to their workers. Based on the sample results, can you conclude that there is a higher proportion of US companies offering high deductible health insurance plans to their workers in 2016 compared to 2015? Conduct your hypothesis test at a level of significance of 0.05. Now, we just can't compare the two sample proportions and say, well, one's bigger than the other. We must account for sampling error, so that is why we run the hypothesis test. First, let's set up the hypothesis test based on the context clues given in the problem. It says, can we conclude that there was a higher proportion of companies offering these types of insurance plans to the workers in 2016 versus 2015? So we can write the alternative hypothesis that the population proportion for 2016 is greater than the population proportion for 2015. Then the null hypothesis is the opposite of that, and the population proportion for 2016 is less than or equal to 2015. We were told to run the hypothesis test at a 0.05 level of significance, so that is the alpha. So, is this an upper, lower, or two-tailed test? As we learned from the prior slide, since the greater than sign in the alternative hypothesis is pointing to the right side of the curve, this is an upper-tailed test. Next, we need to calculate the sample proportions for 2016 and 2015. In 2016, 30 of the companies in the sample offered this type of insurance out of 120. So we take 30 divided by 120, and we get a sample proportion for 2016 as 0.25. Then for 2015, 21 of the companies offered this type of insurance out of 100. So we take 21 divided by 100, and we get 0.21. Now, to get the pooled estimator for the overall proportion, we need to carefully plug in the values for sample proportion 1 and sample size 1, as well as sample proportion 2 and sample size 2. So we plug in 120 for sample size, or N1, in the numerator and denominator, 0.25 for P1, 100 for sample size 2, or N2, in the numerator and denominator as well. Finally, we have 0.21 for P2. Plug this into a calculator and we get 51 in the numerator and 220 in the denominator. Take 51 divided by 220 and we get 0.2318. We can now state the decision rule that we reject the null hypothesis if the calculated test statistic Z is greater than the Z critical value. Otherwise, do not reject. So I've shown how to find the Z critical value already in prior videos, but as a reminder in Excel, you could enter equals norm.s.inv and then 1 minus the alpha of 0.05, and we get 1.645. So here's our formula for the Z test statistic. So like before, we need to be careful in plugging in our values. So in the numerator, we have the sample proportion 1, or 0.25, minus the sample proportion 2, or 0.21. The hypothesized population proportion difference is 0, so that's why we have a 0 here. Now in the denominator, we plug in the pooled estimator for the overall proportion estimate of 0.2318 for P bar here, and then sample size 1 of 100 and sample size 2 of 120. So 0.25 minus 0.21 is 0.04. In the denominator, we'll take 0.2318 times 1 minus 0.2318. Then we will multiply by 1 over 100 plus 1 over 120. Then we'll take the square root of that whole thing. If using a calculator here, you want to make sure you input everything correctly, and we get 0.0571. Finally, we take 0.04 divided by 0.0571, and we get a Z test statistic of 0.701. Now, 0.701 is here, and this is below 1.645, or in the do not reject region of our curve. Therefore, we do not reject the null, and we can conclude that there is not a higher proportion of companies offering high deductible health insurance plans to their workers in 2016 than in 2015. All right, everyone, that wraps up this video on hypothesis tests for two population proportions. That also wraps up Chapter 10.